see. After this, that's a question. If you want to take a picture of it in the next 5 seconds. Oh, I need to get my thing out. You've got this and this. That leads to 30 sodium by mass. What is the question mark is, you want to know the percent NaCl in the mixture. Okay. So 31.7%. The percent mass means 100 of the total. Oh no. Okay. It was about to disappear. Of the total over what you're interested in is the sodium. I'll put this mass. Total mass. Is that okay? All right. So let's say this is mass X, and let's call that mass Y, just so to make life a little bit easier. And then if NaCl had a mass of X, let's see how I write this. X grams, there we go. If that was X grams, I want to find the mass of sodium. Okay? So I would go the molar mass of this from the periodic table. And then there's 1 mole of sodium for every 1 mole of NaCl. Or in other words, there's 1 sodium in every sodium chloride. Okay. And then molar mass of sodium to get to the mass of sodium. That's from NaCl. Is that okay? All right. Next, I'm going to do the same kind of thing, but for the other one. Do you want me to write it all out, or you get the idea? I can write it out. Just write it out. I'll write it out. Okay. So Y grams, that's a Y. Okay. Same sort of thing, moles. So notice I'm going to repeat the top. I'm just doing it with a different molecule. There's 1 mole of sodium for every 1 mole of NaNO3, or there's 1 sodium in the whole molecule. Okay? Then the molar mass of sodium, I think it's just 22.99. Let's double check. Yeah, from the periodic table. Okay, this also gives you the mass of sodium. Is that all right? Okay, now I'm going to do some fancy pen color stuff. This and this, where am I going to put those things? Numerator or denominator? Yeah, I'd put them up here. I'd add them up. Yeah, there we go. Add them up and put them up there. Is that okay? That's the total mass of the sodium you got. What am I going to put on the bottom? X plus Y, right? Is that okay? The total mass of everything, So far, so good? Okay. Then, let's get a different color. The percent of sodium chloride is 100. So you always multiply by 100. The mass of sodium chloride is X, and the total mass is just X plus Y. Okay, you need to multiply this all out. Let's see if there's any other information. And hopefully you can solve for both X and Y here. I haven't like written it out, but just thinking in my mind, hopefully that works. Do you want to give that a shot and then tell me if you get stuck? Oh, this is mine. This is yours. I was going to keep it. There you go. Okay, give that a shot. I think that's my first take at it. Okay, who's two? Oh yeah, you're two. Yeah.
So in the test, they give like one X and one Y.
Do you guys know what's X and what's Y? Not yet. So hopefully you can find that. I'd have to keep solving, but I want to just keep going. So I told her to solve it, or you can solve it too and see if you get stuck. Okay, two. I want to get to as many people as possible. Yeah.
I just have two logistical questions about the test.
Okay, my test or?
Yeah.
Yeah.
So do you need Scantron?
Do you need Scantron for my test? You can bring it, but you won't use it. You'll use it for the final though.
Okay. What about graphing calculator?
Can you bring a calculator? Yes, it can be a graphing calculator. You can't use a cell phone. If you've had programs on your graphing calculator that you inputted, you need to clear them. If you've never done that or don't understand what I'm talking about, then you probably don't have it. Yeah, so that's fine. You won't really use any of the functionality of the graphing part of the calculator in Chem 2A or Chem 2 in general. So that was it?
Yeah.
Nice. Three. Yes. Okay. Let me show it right there. The question's about mercury. Mercury as an ion could be mercury 2. This is mercury 2. Or mercury 1 is not that. If you don't remember, it's this. So it always exists as a dimer. So if I wanted mercury 1, what's a crazy one? Let's just start with nitrate. Then you would go Hg2, 2 plus, and a nitrate. So you need to put the, it's 2 of these, so you need 2 of these to balance the charge. Is that okay? And you cannot factor these numbers down because that 2 cannot go away. Is that the question you were asking? Yeah, cool. Yes. Hg2, 2 plus, people making up their own questions here. And the sulfate, that one? Okay, so 2 and 2. You just need 1 of each. So again, the 2 can't go away, just like in the 4 can't go away. All right. 4? Yes.
I have a question about ionic reactions. I don't know, like, when you want to sample salt or when you want to use have it on opposite side, but then my question is I don't know ionic reactions
Okay. I think I got it. I'm looking over in my reader to page 34. Solving method for consecutive reactions was the question. What do you do with the signs? This is my style of solving, what you've seen in class. If you're matching the overall reaction, then you need to get the item of interest on the same side. So that's what you saw in the example I did today. I was getting on the same side. So if it was already on the correct side, then you saw a positive sign. If it was on the wrong side, you saw me have a negative sign. You did not see me use strategy 2 because I didn't need to. But if there's intermediates, you need to make sure they're on opposite sides. So if they're already on the opposite sides, then the new one you just keep a positive multiplier. But if they're not on opposite sides, they're on the same side, one of them needs a negative multiplier to flip it over, so that they're on opposites and then they automatically cancel. So this is a strategy I would recommend. Yeah. Does that kind of answer your question? You want to do a couple examples to get the feel for it, but maybe have this in front of you. Know which strategy you're doing. I think the question I got today when I was solving it was because the person thought I was doing step 2, but I was really only doing 1.
So like the intermediate of the ones
What's an intermediate? It's something that cancels and does not appear in the overall reaction. So an intermediate is something that does not appear in the overall reaction. Is that all of your questions?
Yeah.
5. Yes.
I have a question on exam paper 17.
Okay, and I'll have to borrow yours.
Okay. Well, I was just wondering about the wording of one of the questions. Like, it's about like the ionics. It says like sulfuric acid reacts with barium hydroxide in water. Would that mean that barium hydroxide is on the
Yeah. Usually that's what I mean. So if you're gaming the exam and you're doing a net ionic equation, if I say they're aqueous or they're mixed in solution or they're water, I probably mean that both the reactants are aqueous. You can always double check on the solubility rules, but that's probably what I mean. There's some exceptions, but let me double check. What number are we doing?
17.
But it's always good to check. That's usually what I mean. 17. It's aqueous there. Right. Oh yeah, I did have a question about this that year. I avoided this issue on this exam. Yeah, but the issue was with the solubility rules, but I haven't wanted to change the solubility rules because other instructors use the same rules on the final. But there's some molecules that don't fit it nicely, so I'd have mercy on grading on this one. But one thing that doesn't fit nicely on the solubility rules is some of the group 2 hydroxide are aqueous. And barium's one of those. Yeah. So now what I'm doing is just avoiding the issue. Yeah. Or I'll say in the problem aqueous something. So if it literally has the word aqueous, I definitely mean it's aqueous. Were you fine? 6. Yeah.
I was wondering if you could explain problem 16 from the winter 2016 exam.
It's a practice exam.
Yeah.
Winter
2016.
Winter 16. Winter 16. What number?
Problem 16.
Winter 16, number 16. Oh yeah, this is exciting. This is one of the hard balancing questions. All right, for this example, I gave you the coefficient for the first one is 1, but to make the problem more exciting, I gave you variables for the subscripts, and I want the answers in terms of those given variables, x, y, w, and z. So there are no numbers in this example. You have to use the variables. So just take it one step at a time and do exactly what you would do for numbers if there were numbers. So for example, CX. C only appears here. So if I want X of them, I'll put an X there. So there's X carbons on both sides. Hydrogen only appears here and here where my pens are. So I want Y, so what variable goes here? Y over 2 times 2 will be Y. Yes. I'm with you. Okay. N is only here and here, so W. So there's WNs on both sides. The toughest one is the oxygen. So I'm going to use scratch paper for the oxygen down here. Okay. Let's pick a new variable. What's your favorite letter in the alphabet?
A.
A. Good. Mine too. Okay. So, on the left-hand side, you have Z plus 2A. Is that all right? I made my line too long, but that's okay. So the total number of oxygens on the left is Z plus 2A. On the right is 2X plus Y over 2 plus 2W. Is that okay? All right, again, I'm solving for A, because A is the variable you made up. But I don't want it in terms of A, I want it in terms of the other variables. So you just set up an equation. Z plus 2A equals 2X plus Y over 2 plus 2W. Or 2A equals 2X plus Y over 2 plus 2W minus Z. Or A is 1/2 2X plus Y over 2 plus 2W minus Z. Zoom out. Look okay? Okay, I know it's exciting. Okay, you were 5 or 6? 6, 7. Yes.
Exam 1, fall 2015.
2015 practice exam. Number. I guess the one that's circled. Oh yeah. Here's another way to do a molarity question. Number 8, fall 15. Is it okay if I show you don't even have any? You just have a circle, so it can't be identified. Okay, this one. Okay, a solution is made by adding enough water to increase the volume. So you've got calcium hydroxide stock solution. That's what you get from the stock room or the dispensary. You're going to add a water such that the volume is going to go up by 4 times. Okay, so the molarity will go down by 4 times. So you already know that the molarity is going to go down 4 times if the volume goes up 4 times. Okay, what was the concentration of calcium in the final solution if the stock solution was, yeah. Okay, this is better than I thought it was. Okay, I have to move this. Okay, so let's kind of break the problem down. If the stock solution is 4 molar in hydroxide, so it's 4 molar in the hydroxide ion, but we're not talking about the hydroxide ion, we're talking about this. So, in case you can't do it in your head, I'm going to write it out. But I need to know the molarity of this, not the hydroxide, in order to do the problem. Okay? So, 4 molar hydroxide, there is 2 moles of hydroxide for every 1 mole of calcium hydroxide. Hello? So, or in other words, there's 2 hydroxide ions in 1 molecule. Okay. So really, the molarity is 8 molar. Is that okay? So now we can do the question. What was the concentration in the final solution if this is stock? So what's the final concentration? Okay, just a second, let me write down the number. I think it was 2, right? 8 divided by 4. Yes? Oh, did I do it backwards? Nice. Yeah, I wrote it backwards, thank you. So it's not 4, it's 2. Yes. Excellent. So this is...
Wait, so it's 1 mole CaOH over 2 mole OH?
Yeah, C to minus 1 mole. So, yeah, I was canceling out the hydroxides. So if I get 2 for the stock, the final concentration is 0.5 molar calcium hydroxide. And since there's 1 calcium for every calcium hydroxide, that's also the calcium 2+ concentration. You okay? Okay. Thank you, person over there, wherever you went. Was this yours? Yeah. Let's see what time it is. 7 minutes. Next round. 1. I try to take like 3. Or just 1. Good. 1 question.
Okay.
I guess you are the last question. Fall 17. This was an exciting year for everybody. Number 11. What was the average? 63? Okay. The isotope question? Yeah. Oh, okay. Here's a question right here, 11. 11, they're top of the screen. More neutrons than protons. This is an isotope of what element? Okay, let me move I'm going to move the question now. Okay. So we've got 11 more neutrons than protons. So that means protons plus 11 equals neutrons. Is that okay? Okay. Now, the mass number is what? The sum of what? The protons plus the neutrons. Is that okay? So, let's do that in different colors. We know this is the protons plus the neutrons. What am I going to do here? I probably just substitute that in there and then solve the protons. Is that okay? Can I let you do that? Wherever you want to shoot.
Yeah, I'm confused because I thought the mass number was like the red number once we got a table.
thinking of the atomic number, I think.
Oh, okay. Okay.
Is that all right? Okay. Oh, wait, I was going to give you back the transparency. Here. Okay, I think that was the last question. I hope you had a fun time.